n is an integer greater than 1. Use algebra to show that n squared minus 1 plus n minus 1 squared is always equal to an even number. So n is an integer greater than 1. Right, so if we have n squared minus 1 plus n minus 1 all squared, so always equal to an even number. Now an even number would need to have a factor of 2. So let's just try this out. So let's just keep this in mind for now. So let's expand this out. So we've got n squared minus 1 plus n minus 1 all squared would be 2 sets of brackets of n minus 1. Now if I have n squared minus 1 plus, from here, if I remember FOIL, you can write out like this if you'd like, or do it quicker. FOIL, so the first of each term would be these two. So n times n would give n squared. The outside terms would be n times minus 1, which would give us minus n, minus 1n or minus n. Then we have the inside, which is minus 1 times n, which again would give us minus n or minus 1n. And the last, which would be minus 1 times minus 1, which would give us plus 1. Remembering that 2 minuses when times will give us a positive sign. So if we write all of this here to the left, we end up with n squared minus n plus 1. So simplifying this, we end up with n squared minus 2 lots of n plus 1. Now at this point, we can collect some like terms. So I'll just underline some like terms for now. Okay, so looking at this, we've got n squared plus n squared, so we get 2n squared. We then have minus 1 plus 1, or minus 1 plus 1 will give us 0. Therefore, all we have left is minus 2n. Now at this point here, remember at the beginning I mentioned that for it to be an even number, it has to be a factor of 2. You can see here that there looks to be like a factor of 2. So what we can do is we can factor this out. So don't forget, factoring means to pull out the highest common factor or to put it into brackets. So we could put 2 here and 1n, open that bracket up, and then make this n minus 1. So this is what we end up with so far. So let's see if this actually makes sense. N is an integer greater than 1. So if it's greater than 1, then we could use n equals, let's say, 5. Okay. So here, use algebra to show that this is always equal to an even number. So let's have a look. If we put n as 5, because it just says any number greater than 1, so say put n as 5, let's try this. So we've got 2, open bracket 5, open bracket 5 minus 1. So if we do 2 times 5, that will give us 10. Open bracket 5 minus 1 will give us 4. And then 10 times 4 will give us 40. Well, that's given us an even number, hasn't it? Let's try n equals 3. Okay, so then we've got 2n, n minus 1. Then we've got 2, bracket 3, 3 minus 1, close bracket. Then we have 6, 2, which gives us 12. Okay, so you can check this one more time. Let's say with 10. It's a good idea to, once you've done the algebra, to actually check this. So number greater than 1, and go for several values to show that you're trying to show on top of the algebra, you're actually trying numbers in to see if it makes sense as well. And it's a good way to check that the algebra you've done is correct. Okay, Because remember, when it says show that, generally it means that that is the case, and you just need to prove it. Okay, so don't be tempted to say it is not the case and you don't get an even number. So back to this, so we've got 2, open bracket 10, 10 minus 1, which gives us 20, open bracket 9, because 10 take away 1 is 9, and that 2 times 9 is 18, and there's a 0, so 180. So again, all of these numbers here are even.